But first, wind generators harness the power of the wind to produce electricity. As the turbine's blades revolve, they drive a rotor that generates power. This can charge a set of batteries, or even feed a transmission grid. Wind power is a renewable energy source that doesn't pollute. This type of wind generator is a recreational model, designed to power a small dwelling with up to 500 watts of electricity. To make the propeller, a template is laid on a plank of cedar, a rot-resistant wood that's flexible and durable, yet lightweight enough for the slightest breeze to set it spinning. After tracing, workers drill a hole at each end and in the middle, then remove the template and do a rough cut using a bandsaw. Then they put the template back, using those holes they drilled to align and secure it in place. Using a router this time, a precision cut is made. The plank of wood now has the contour of a propeller. The next step is to form the profile. To do that, the wood is bolted onto the right side of a specially designed device called a propeller carving machine. On the left side is the propeller model. After adjusting the model to the proper angle, they start to cut. As the machine's roller runs over the model, it guides the shaper to carve the wood exactly like the model. It takes 8 passes to get the profile just right. Once the ends have been marked and the excess cut off, it leaves one side flat and the other curved, like an aeroplane's wing. Now workers widen the hole in the middle of the propeller and sand off the ridges left by the carving, using a low-pressure inflatable drum sander, the only type flexible enough to really get into the curves. Next they check the balancing, which is so sensitive a penny could spoil the equilibrium. Finally, a coat of waterproof epoxy paint is applied. Next, the alternator is assembled. This is the component that generates electricity when the propeller spins. Insulation is wrapped around what's called the proportional electronic regulator. It's then installed along with wiring into the alternator's casing. This regulator controls the electrical charge and current. The propeller spins this rotor shaft, creating an electrical charge that sends a current from the alternator to the batteries. Once the casing's bolted shut, a cooling fan is mounted on the shaft's protruding axle. This fan will expel the heat that the spinning generates. Next, workers assemble the parts that make up what's called the lolly shaft, the axis on which the propeller sits. The axis enables the propeller to pivot towards the direction of the wind without twisting the wires that run to the batteries. Finally, they connect the wires from the lolly shaft to the alternator. This rubber cover protects the connection from the elements. Now workers assemble what's called the propeller governor, a key component that prevents the propeller from overspinning and breaking down in high winds. When the propeller spins too fast, the centrifugal force pulls on these springs. This activates the braking flaps, generating drag to slow the propeller down. Again, precision balancing is critical, otherwise damaging vibration will occur. The propeller's rudder is then mounted onto the back end of the wind generator's frame. On the other end, the alternator is fixed, followed by the propeller and propeller governor. They're both painted to protect against the sun's UV rays. Now, we just need some of nature's breath to get the whole thing going.